Alright, so the last thing we're going to review here today is multiplying polynomials. Okay, now earlier we talked about the fact that when we add polynomials or add terms, we do nothing to their exponents. This is going to be a little different in that when I multiply bases, I add, let's do that in all caps, their exponents. Okay, and a quick little reminder as to why that is. If you think about, the side example of, I don't know, let's say x to the third times x to the fourth, well, you may go, oh, well, that would be x to the 12th. Well, it's not, because think about what x to the third is. X to the third is really x times x times x. Okay? And that's being multiplied by x to the fourth, which is x times x times x times x. So what are you left with? You're left with x to the seventh power. So for that reason, the rule becomes when you multiply common bases, you add their exponents. Now once again, this is one where in the book, we're going to do the distributive property here. The first step that they show you in the book is actually multiplying, like rewriting this with a whole new set of multiplications. I would do an arrow here, probably a different colored arrow here, and a different colored arrow here, and that would probably be the extent of how I would show what's being multiplied. I don't think it's terrible, especially when we're first reviewing in the book, in part A there, the second line, that they actually write out, okay, here's what you have after you distribute. Because that can help you get back into the swing of, okay, here's what I'm multiplying, what do I get? So what they're going to do here is they're basically saying, okay, 4x squared times 2x to the third. That's that first multiplication there. And then the blue multiplication is 4x squared times negative x squared. And they're just going to group that little piece. And then the last one they're going to do is 4x squared times 5. Okay? That's not necessarily a step I would do all the time, but it doesn't hurt to write it out, because it might kind of help you see, okay, a little refresher on this multiplying business. Okay? Now the one thing I didn't say when we down in the corner here, when you multiply bases, you add exponents. But when you're talking about the lead coefficient, or the coefficients of these terms, like the 4, oh, let me undo that, I don't like that purple arm around there. Like the 4 and the 2, we're going to go ahead and actually multiply those, because those, we just multiply those the regular way. Because as a side note, again, remember, when you're multiplying, you can multiply in any order you want. So for that red part, I could actually write that if I wanted to as 4 times 2 times x squared times x to the third. So I could even go a step further to break that down if I really wanted to. So 4 times 2 is 8. And when you do x squared times x to the third, we actually add those exponents. That leaves me with an 8x to the fifth. Plus, now in the middle here you have a 4 times an understood negative 1. Okay, so here's your 4, here's a negative 1. 4 times negative 1 is a negative 4. And when you do x squared times x squared, well, 2 plus 2 is x to the fourth. And then lastly, you have 4 times 5, which is 20. X squared doesn't have anything it needs to pair up with. And I'm all set. Add exponents together when you're multiplying common bases. Look at one more of these. In your book, this one would be the second example, example B. Okay. You know, the book is good for a lot of things. On these, I don't want to like reinvent the wheel. I want you to multiply them the way you've been multiplying them your whole math career. The one thing you have to be sure of here, now this is a binomial times a trinomial. 2 terms times 3 terms. I should have 6 terms when I'm all done multiplying. On the last example, it was a 1 term times a 3 term. So once I got done, see how I have 3 terms here? 1, 2, 3 terms. Okay. On this one, I should have 6. Now, I may simplify after that, but after initial multiplication, I should have 6. So I have the distributive property with the x. I have to do that first. But then I am also going to distribute with the negative 3. So here are where your 6 multiplications come into play. Everything from the first term gets multiplied by everything from the second term. So let's go ahead and let's just kind of write these out what it would look like. So I have x times negative x squared. And then the blue multiplication is x times 2x. And then the red multiplication is x times 1. And then the black multiplication is negative 3 times negative x squared. Then I guess we went purple, which was negative 3 times 2x. And then the yellow is negative 3 times 1. So there's 6 multiplications. Once again, you don't have to write it all out like that, but it may be a benefit just to look at each part differently. So x times negative x squared. Well, a positive times a negative is a negative. This is like x to the first, and remember, when I multiply variables, I add their exponents, so this actually becomes negative x to the third. If I have a x times 2x, that's going to be 2x squared because I'm doing 1 plus 1 with the exponents. If I have x times 1, well, that's just x, 1x. Negative 3 times negative x squared, that's going to be a positive 3x squared, a negative times a negative. Negative 3 times 2x, well, that'd be a negative 6x. And then negative 3 times 1 is just a negative 3. Now I need to look at combining like terms. Now, to combine like terms, they have to have the same variable and same exponent. I know that I have an x squared here and an x squared here, so I can combine those. I also have an x term here and an x term here, so I know I can combine those. The other ones don't have anything to combine with. So I'm going to bring down the negative x to the third. I have 2x squareds plus 3x squareds, that's 5x squareds. When I add variables, I do nothing to their exponents. I have negative 6x's plus 1x, that's a negative 5x's, and then I bring down the minus 3. Nothing can be combined any further because they are all different variables exponents.